to SRE Summit 2024 and thanks for joining this talk. So our talk for today is distributed tracing with Open Telemetry and how it can help with unraveling the complexities of microservices. So who am I? My name is Safir. I've been an SRE, DevOps and platform engineer for 18 years. I've been an engineer. I continue to be an engineer. I'm a speaker and an author. And today I'm here to talk about Open Telemetry. So let us start by talking about the microservices revolution. Now, we are all SREs. We do understand what microservice revolution is, but let's cover the points once again so that, for the sake of completeness. So to understand fully what a microservice revolution or like the microservice architecture means, let us first unpack the definition of microservices. So microservices are an architectural strategy that breaks applications into a set of individual services, as opposed to operating as a monolith, which is the way applications traditionally run. Now, microservice adoption has skyrocketed in the past decade or so, and it has become the new normal. So there is nothing new about the microservices anymore. It is the standard, and it has added a lot of benefits, as we can see. Like it has reduced the code complexities, increased developer productivity, faster time to market, and from the reliability and scalability perspective, it has helped out because individual pieces of your infrastructure or your services can be scaled individually. If there's a fault, it can be isolated quickly. So there are a lot of benefits, and it really has helped us. But like all other good technologies, there are certain problems also with it. So let us look at the microservice complexity. Now, this is an image that I first captured in 2018. It has been 5 years plus now. This microservices Death Star essentially shows the number of microservices that Amazon and Netflix has and their complexity in the and dependency. Now, what are the challenges of microservices? The complexity of interdependence and observability. What does that actually mean? See, it is hard to determine the dependency of one microservice on from on another, right? And the complexity increases exponentially, and each code change can bring in more dependencies. And the inter-service communication depends on what APIs and interfaces each microservice provides, and these things can keep changing, all right? And the other problem is that how can you troubleshoot when a production outage occurs? Debugging an issue becomes a tedious task, and chasing down which request went where and what exactly was the reason for an outage is really difficult. Now, how do we start addressing this problem? Observability. See, the observability by definition is the ability to understand the internal states of a software system by analyzing the data it generates. So it's a continuous process of analyzing and understanding software systems essentially. And the key value of observability isn't in the data itself, but it is what you do with it, right? And it relies on a lot of data like logs, metrics, traces, profiles, events, and the analysis tools to use it. And so it helps you in observability of course helps you in resolving production issues, understanding your business impact, and most importantly your customer experience, right? And it also helps you understand what is the current state of your system, gives you a bird's eye view of the entire thing, and it's a holistic view of a complex distributed system. Now, telemetry is a word that we keep hearing along with observability, right? So what does it mean? See, it is the process of measuring, collecting, and relaying of data. What kind of data? So the most common telemetry data are logs, metrics, and traces. And these are commonly known as the three observability pillars. So logs, obviously, that it's a textual record of a system event. It could be structured or unstructured. Metrics again is a time series of data points on system performance or its behavior. And traces is the journey that request takes through a distributed system, and that is what we are here to talk about today. So there are other types of telemetry data like profiles and events. We are not covering that right now. So what is Open Telemetry? Or as today it's called as short form OTEL. So it's an observability framework and toolkit designed to create and manage telemetry data such as traces, metrics, and logs. And you can easily instrument your application or systems, no matter their language, infrastructure, runtime, etc. Right? And instrumentation is the keyword here. Instrumentation is the process of making a system observable by making it emit logs, metrics, and traces. And this data can be sent to one or more observability backends that supports this kind of telemetry data. So what is the benefit of Open Telemetry? Obviously, there is no vendor lock-in because it's an open standard, which means that you own your telemetry data. How does that help? Now, when the standard of the data itself is not locked in, you could switch between any vendors, any open source tools, migrate data, analyze data right now, or 2 years from now. Because you don't have to worry about what format it has been stored in, or what format it is emitting now. So that is the no vendor lock-in benefit. And of course, with this standardization, there are standard APIs and conventions, which helps with better interoperability of tools. You could mix and match different kind of open source tools, vendor tools, or you could have the data being shared between different type of systems. This is all possible, right? That flexibility is very beneficial. And another cost that we don't talk about in terms of observability or any project, cross-cutting project, right? Is that the engineering cost. Now, if you were to use custom tools, a lot of proprietary formats, things like that, the amount of engineering time that has to be invested into understanding these formats, the tools, and working with them is enormous. Now, with a common standard and common tool set, it takes only a short amount of time to understand something, and probably your engineers already are aware of it, and it makes it easy to train them for them to handle the tools and frameworks and instrument their services. Now, this is a high-level view of the Open Telemetry ecosystem. So, as you can see, there's a whole bunch of things, right? And so, OTEL essentially is a specification for the structure of telemetry data in each of these categories, like logs, metrics, and traces. And it also defines communication protocol between different components, and how other the shape of the data in general should be, right? Again, instrumentation can be done in different ways. Automatic instrumentation of a software is the way in which telemetry data can be generated from a system without actually requiring code changes. If you are okay to willing to make code changes, then you can use SDKs to attach code small code snippets into your application code, which gives you more control to run and observe your system. So the other part in this equation is shared infrastructure. There could be infrastructure services like network, Kubernetes, proxies, cloud vendors. Once you have the same OTEL format, everybody can send telemetry data into one place in a common standard, and that one place is typically OTEL collector. What is an OTEL collector? The central kind of a pipeline which can accept data telemetry for an OTEL telemetry format and send it to different observability backends. On the right side, you can see that there are time series databases, which is for metrics as a backend, trace databases obviously, and column sources essentially for log formats. And then there will be tools built on top, which are built on top of these databases or the observability backends, which can make sense out of it by alerting, analysis tools, dashboards, etc. If you go a little deeper, and this is a different view of the OTEL ecosystem, right? And if you see here, there are APIs, SDKs, and then there is a protocol called OTLP for communication between different components. And what you're seeing here is, let's say on the website, what you're seeing is an application, right? Now let's assume that this is an application written in Java, right? So again, API is an abstract implementation, so it is part of your instrumentation ecosystem anyway. But unless you are creating a library, what you are going to use is SDK for instrumenting an application. And within that SDK, there could be a processor and an exporter. There is a processor and an exporter which can do some pre-processing or enrichment of the data and then export the data out to a backend or to a collector. Now the collector itself has three parts. It can receive data in different formats, different protocols, and it can do a lot of pre-processing of the data, and then it can export again to different type of backends. Now the backend itself is there are Portal has a standard for how to handle that, but again there is a lot of flexibility and pluggability in this ecosystem. And what is the need for distributed tracing? Right, this is a continuation of our the discussion of Microsoft challenges from the earlier slides. So the modern software applications are very complex, as we have seen already. It not only consists microservices, it also has data stores, message queues, and a lot of stateful systems and infrastructure pieces, everything, right? And to serve a request, a microservice will have to talk to a number of services. And depending on, again, a microservice doesn't just serve one type of request, right? There could be different type of requests, different type of workflows, right? And to serve each of this, the service has to essentially talk to different microservices, and the path each time it takes will be different. So with such complex paths, it's very difficult to debug issues, understand what is the big picture, what is how our users are experiencing our product, or even understand how much time each request takes, and where it takes that time, right? So that is why distributed tracing is important. Now, what exactly is distributed tracing to begin with, right? We shortly touched up on the definition in the previous slide, but to make it concrete, it is a representation of a complete journey a request takes across a distributed system. Now, when a request passes through a different services within a distributed system, it causes certain events, right? And traces essentially stitches together all these events and gives you a complete picture. And it also adds a lot of metadata about what are the attributes or configuration data about the service, what is the performance data of the service, the request, how it when the request was processed through a service, what is the kind of performance metrics it sent, etc. Now we talked about again tracing. Now this is what makes up the actual traces, right? Now a trace, as we said again, it's a path of a single request through your application or your distributed system of applications, right? And requests could be made by an application or an end user. Now one of your other microservice might have made this request, or an end user sitting somewhere else outside of your infrastructure might have made this request, right? And when this request is received and it has to be processed, the request will go through different system microservices or systems, and at each of these touch points they perform certain operations, one or more operations, right? And trace is a collection of all these operations put together, and these operations are the unit of work performed. Now each of these unit of work are called spans, and spans contain detailed information about each of these operations. So so essentially a single trace represents a single request, and it will have a number of traces, sorry, some number of spans, right? And different spans in a trace will have either a parent-child relationship or a sibling relationship with each other. So essentially a trace is nothing but a directed acyclic graph of spans. Now, we talked a lot about this, a lot of text, right? So let us see from a picture what exactly a trace is. So what you're seeing here, this entire thing is a trace, a single trace, and this is the time progression that happens. Now each of these rectangles here are spans. So this is a rough representation of part of an e-commerce transaction. So there's a client which hits an API for some service, right, and an e-commerce service supposedly, and the API has to first authenticate and authorize this request. So it sends certain details to an authentication service. Now the authentication service authenticates the request, identifies the user, and then it sends the request further to an authorization service to understand whether the user is permitted to take this action. And once authentication service gives a go ahead, the data is returned back to authentication service. The authentication service returns the data back to the API service. Now that the API knows that the user is allowed to perform this operation, it sends the request further to a payment gateway for payment. The payment gateway service obviously will have to talk to some databases, some external service and merchants to complete the transaction. And once this transaction is completed, payment gateway will tell the API as the purchase is done. So since the purchase is done, the API will further talk to dispatch API to figure out whether the product is dispatched or allotted to a driver. And the dispatch service in itself will call another endpoint called search to find out the order. It will keep on calling another endpoint until it gets an ID for its transaction, and it will keep calling the another endpoint called poll driver to understand whether for this particular transaction is a driver allocated. And once that information is received, it will return through this entire chain back to the API, and the API will return to the client saying your operation is successful. So this is what happens with trace and spans, and this is like a waterfall representation. So I hope this gives you some idea about what trace and spans are. So a little bit more details about spans, right? As we talked earlier, it's a unit of work. And for example, an HTTP request to a web service is a unit of work. A query that is made from a code is a unit of work. Now, if your service calls another function from within your a function, that is also a unit of work. Now, it contains, as we mentioned earlier, span contains a lot of data. The primary one is the span name, or which represents the operation that the span is performing. And there will be a parent span ID, obviously, and there will be timestamps of when the operation started and ended. There will be something called span context, which we'll look into later. There will be a bunch of attributes. There are events, links, and status. We will look at it again in the next slide. So before we look further into spans, what is context and context propagation? So every trace has a unique trace ID, and every span has a unique span ID within the trace, right? And the first span in a trace is the root span, which has no parent. All right, and obviously there's a parent-child relationship here. Now what happens is the context contains the information about the current span. It talks about so the context essentially gives you a trace ID and span ID, and when let us say a request passes from one microservice to another, it also carries this context of trace ID and span ID. Now the second, let's say a microservice passes this context information to the second microservice, which calls. At that point, second microservice realizes that look, this request is part of an already existing trace, and there is a parent span already. Now the second service instruments it's part of the request, and then emits additional it creates another span which will be a child of this particular span, and that is how the context propagates to all different microservices and creates this whole chain. Now this is the structure of a sample span. As you can see, there is a name which describes the endpoint in this case. Now the context is basically a trace ID and a span ID, and then there is a parent ID. There should be a parent ID, but there is no parent ID here because this is the root span. Start time, end time, what is the status of the span, things like that. Most of these are obvious, and these are all attributes which are key value pairs that gives additional context information about your span itself, span and the operation itself. And there could be some events. These are optional, but there could be some events associated with the trace. A little bit more information about spans. Attributes are nothing but key value pairs that contain metadata. And then there are span events, which are like some structured log messages related to the span. Then there are span links, which are like loosely coupled relationship with another trace or another span. Then there is span status, which indicates the status of the operation itself. And then there are span kinds, which specifies what kind of service give this span. It could be client, server, or by default it could be called as internal or if you are in a async operation, it could be a producer or consumer. So we have a decent idea about what observability is, what Open Telemetry is, and how distributed tracing works. Right. So let us complete this with demo. Now this is a small part of an e-commerce workflow. So every e-commerce service has a product page, right? And there will be a UI that displays all the details of the product, including whether this product is available to be delivered to you. Now, the way it is going to work here is the product page UI is where you are supposed to see the product page product information, and to get the information required to display on the page, the product page UI service will send a request to the product page API with your username and the product ID. Now, product page API has to collect a bunch of information and send it back to the product page UI. What it is going to do is, first of all, it will talk to a catalog API to get more detailed information about the product. And the catalog API, of course, has all this data in its a document database, which is MongoDB, and it retrieves the data and send it back to the product page API. Secondly, the product page API will query the address book API to find the current address of the user, which again is stored in a MongoDB, retrieved and sent back to product page API. Thirdly, product page API will send the request to a service called serviceable API. Now, in the world of e-commerce, serviceability, there are different terms for this, but serviceability essentially means whether a product can be shipped to a user. In certain cases, when you browse certain products, you will see that this item is not available in your area or your region, etc. Right? Now, that information comes from this kind of a service. Now, how does this work? The serviceable API takes both the product ID and the pin code from the address of the user. First, it will talk to the inventory API and figure out whether this product ID is available, and if it's available, in which all warehouses. So the inventory API will talk to the MySQL database and send back a list of warehouses if the product is available in those warehouses. Now, secondly, the serviceable API will send the pin code to the warehouse API to see which all warehouses serves this pin code. So again, the warehouse API also talks to MySQL database and returns a list of warehouses. Now, the serviceable API will mix and match these two inputs and figure out whether the product can be serviced or not at this pin code, and then it sends a yes or no back to the product page API. And this is the entire transaction. Now, once the product page API gets all this information, it will send it back to the product page UI. Right? Now, let us go and run the actual demo. So we are going to make a curl code representing the UI. We are going to hit the product page API using this curl code. If you see the API code, I am sending two arguments here. One is a user ID, and then there is a product ID. Let us see what it returns. So as you can see, there are three pieces of information here. Right? One is the address, obviously, along with the pin code. The other one is the product information. If you can see the product ID here, and then it says this is serviceable, which means I can ship or buy and ship this product into my address, which is located at this pin code. Now, this would have kicked off like the entire workflow that I described earlier. And let us go to the Jaeger UI. So before I talk about Jaeger UI, I will just quickly circle back to the presentation, just to tell you a little bit about this setup. So all the microservices that are written in Python Flask, and all these microservices are auto-instrumented, which means I haven't written any custom code for instrumentation of these services. There are pre-built libraries and tools which can actually look at Flask code, inject code into the Flask application, and do auto-instrumentation. Now, the auto-instrumented Python frameworks in this particular scenario are obviously Flask is the first one, and then there is the request library, which is the HTTP library for Python. Then there is MySQL connector and PyMongo, which is for the MongoDB, right? And the trace backend is Jaeger, which is an open source tool for storing traces and displaying it. There is no auto collector in this case because it's a simple setup. So from the Flask application, you will be directly sending traces back to Jaeger. Now we have already sent this query into the product page API. Now let us go to the Jaeger UI and figure out where our request went. Okay. So what you are going to see here is a list of services. Now in the world of traces and Open Telemetry, there is a concept of services where each of your microservice or systems that is in your infrastructure that can be instrumented is a service, and it will have unique service name. Now in our infrastructure there are 6 microservices if you remember the architecture, and you can see there are 7 services here, right? And one of the services is Jaeger itself, which we will ignore, but other than that there are 6 services already here. And what we hit was the product page service, right? So we will pick up product page service and find traces associated with this service. All right, so now what you are seeing is a single trace which was generated 2 minutes ago, because we made the query 2 minutes ago. As you can see here, right, there are 15 spans in this trace, and you can see that what are the individual services involved in this and how many trace spans belong to each of these. Let us click this trace. So this is the view that gives you timeline of the trace, like what happened at what time. If you see here, the entire request took 86.34 milliseconds, and this is the top span. Now this span, if you see here, right, so here you can see that product page -svc is the service name. Then there is a slash product page, which is the span name. Let us just click this particular span. So this is the first and the foremost root span. If you see here, this length of this span, right, it shows that it started at 0 microsecond and finished and persisted through the entirety of the request, right? So because this is the root span, obviously it will persist through the entire request, right? So the curl code we made hit slash product page and it generated a span, the first span. And these are the attributes that it generated. Most of it is self-explanatory. As you can see, the arguments that we passed is here, the endpoint we hit is here, and the path is also here, right? And if you see here, how did we get this data? It says Open Telemetry.instrumentation.flask, which is a library which is used for auto instrumenting Flask. Okay. Now let us just fold this one. So what would happen once we hit this endpoint? The first thing it will do is, if you remember, the product page service is going to hit the catalog API to get the product information. So within product page, now it is going to be an HTTP request, right? That initiation of the HTTP request is what you are seeing here as a second span. The span name is get. We are still in the product page service, and the get method, again, this is self-explanatory. What is the URL it is going to hit, and again, the library that is used to instrument this is Open Telemetry.instrumentation.request, which is the Python request library's instrumentation framework. Now again, let us fold this one and see what happens next. See, till now we have been in the product page. Now we are crossing over to catalog service, which is a child span of product page service get. Now if you see here, again, the attributes are mostly self-explanatory, but you can see that it hits slash catalog. So product pages, you see, hit the slash catalog with this argument, and again it was instrumented using Flask, Flask library. Let us fold this one and see the child span here. Now if you remember the workflow, catalog service had to retrieve the product information from the MongoDB, right? What you are seeing here is essentially the span name is catalog.find, which is essentially the query that the PyMongo library made to the database. And if you see here, it clearly says this is a MongoDB service, the statement used is find, and the database name is catalog, and the collection name is products, right? So once this is done, the product information is retrieved, and then catalog service sends this data back to products SVC. So this operation is complete now. Now again, the control is back in product page service, and the product page service launches the next request, which will go to the address book to find the address of the user, right? And again, the attributes are self-explanatory, so we will not touch that. Now what happened, this request is now going to the address book service. Again, the address book service knows, like, the, you can see the attributes here. And where should it retrieve the address from? Again, from, like, another MongoDB. So as you can see here, database name is address book, the collection name is addresses, and of course the statement of the operation used is find. So once this address is retrieved, it is sent back to the first page. So this operation is also complete, and the control goes back to production service, and it makes a third and final request. To which service? The serviceability service. All right. Now, if you go down to the next span, the server hits the serviceability service, which actually has to make two calls, one to the warehouse service and one to the inventory service to retrieve this information. Now, the first one is, of course, like warehouse service. You send the request here. If you see here, the argument is warehouse and the pin number, pin code of my address, right? And warehouse will return a list of services. To do that, it has to first talk to MySQL. And if you see here, the span name is select, and it also mentions which is the database name and what is the query used. So this gives you plenty of idea about, like, how exactly the request is going, right? And similarly, there will be again, once this information is retrieved, serviceability control will return to the serviceability service, which will then query the inventory service, and the inventory service will talk to its database, and again, like, retrieve the information and send it back to the serviceability service, at which point serviceability service can calculate what happened, or, like, whether this product is serviceable at this particular pin code, and that information will be sent back to the product page service, and this completes the transaction. Because once this is done, the entire control goes back to this product page service, and then the data is returned to the product page UI. Now, there are different ways to, like, look at a trace, right? And this is the easier the default view for analyzing the trace. But let me show you another view. So this is the graphical view, or the graph built from the traces. So this is what shows you the entire picture, right? So the product page service launches another get operation, talks to three services, and the first service again talks to a MySQL database. Second service, sorry, MongoDB database. Second service again talks to MongoDB database, and third service then talks to two services, which each of which talks to MySQL databases. So this gives you, like, a bird's eye view of, like, the entire request. And then there are, like, of course, like, if you have multiple requests, you can actually see, like, how much data is collected, what is the average, and, like, all the statistics about how much time it took to serve certain requests. Then the spans themselves, you can inspect them. There is a table for that. And if you want to see the raw data, that's also possible. This is not exactly in the Open Telemetry format. This is a Jaeger custom format, but you can see that there are trace IDs, span IDs, and the span names and things like that. So I'm pretty sure this would have given you a decent idea about how the traces can be used. Now think about a scenario, right? Let's say let's go to the graph view, right? Now if this MySQL server was to go down, or let's say it takes, usually it takes, like, how much time, 0.78 millisecond, or let's say 1 millisecond it took. Then let's say there was some problem with this MySQL server and it took 50 milliseconds. And how would you see it as from an end user perspective? You will see that the request which was taking 80 milliseconds earlier is now taking 130 milliseconds. Now how do you find out what is going on? You traverse to the trace. At some point you will see that, like, this fellow is taking a lot more time, right? And that is how you can troubleshoot complex microservice architectures. I hope this gave you some idea about, like, how you can troubleshoot certain things. And again, this is a very oversimplified view of how a microservice architecture would work, but this logic and this method works for troubleshooting any of the microservices, and that is why distributed tracing is very important for microservice architecture. So let us get back to our slide. So our presentation has come to an end, and feel free to connect with me. I am on LinkedIn, I am on Twitter, and this is my blog. and this is the book I have written. So feel free to connect with us, and thanks a lot for listening.